While Rebecca is setting up, let's please call in Mr. Paz from Microsoft, one of the sponsors, to give the 2-minute pitch. Thank you. And, well, good afternoon. How have you been? I hope you've had fun. What a great show. I am Wilson Pais. I'm from Uruguay. I'm settled in Chile. I am the Director, Innovation and New Technologies at Microsoft for the whole region. I am a developer. I was a developer for a long time, since I was 8 years old until 30. I no longer program at the rate that you normally do, so don't invite me to do so with you, because I might slow you down. But I'm highly connected with technologies, innovation. I studied mathematics. I have a PhD in maths. I'm an engineer, and I've always worked in software making. So I originally had these companies that I sold before joining Microsoft. I joined Microsoft to start selling Windows 95, among others. I'm not that old either. But anyway, let me just give you this message from Microsoft. It is that Microsoft is a company that was originated in 1975, creating tools for developers, the first tools ever, like the ones that were built by Bill Gates himself, a compilator, and tools for different microcomputers. And today we continue to bet on the same, to deliver technologies and new ways for developers to develop software piece on the cloud, enable them with, or give them tools. We've learned so much these last years. And we have tools for them to develop in different areas: Mac, Linux, Android. We took over Summary, that is a native mobile development tool company. We ourselves, we've also delivered our .NET framework, and we're taking that framework to all of the platforms so they can program in just a single language for every platform in a native fashion. I hope that you have enjoyed the two talks, two key speakers we brought down. The person we brought down, James Montemagno, he's from Xamarin, takeover process, and he is in the platform application development. There's Donovan Brown, who is the DevOps expert that I'm sure he talked about the whole transformation of Microsoft towards Agile. This change that Microsoft went through. Instead of just leading versions of Office, Windows on the products we do every 2 to 3 years, we are sending releases every month or every 3 weeks. I guess he was explaining about this transformation of Microsoft. And just to wrap up, let me just leave you with just a web address, just one, visualstudio.com, which is for a free platform for agile development and DevOps development, so you can integrate with the tools that you normally use. Thanks a lot for the time allocated, and I'll turn it over to ThoughtWorks representatives now.
Hello.
Próxima charlista.
Our next speaker, Rebecca Parsons. She is the CTO at ThoughtWorks, with over 20 years of experience in the development of applications industrially. She used to work in telecom and emerging internet services. She used to be an IT professor at the Florida Central University, and she is a co-author in several books. In her talk, she will talk about ThoughtWorks and how they implement the business skill from continuous design over to continuous deployment and delivery.
Buenos tardes. I guess I should have used hola rather than
Debía haber dicho hola.
I am now out of Spanish except for gracias. I will use that at the end. I know there's only 2 talks between now and drinks, so I'll try to make it quick. But I want to talk about business agility. And this is how we start to think about, as organizations more and more are becoming technology companies that happen to do things like banking or travel or mining. These organizations need to think about, how do I make technology work better for me? How do I make it go faster? How do I provide more value to all of my users, whether they be my end customers? Maybe they're my suppliers or partners. Maybe they're actually the people who work for me and have to use the horrible systems that we've all created for them in the past. And so I want to talk about a virtuous cycle that includes continuous design and continuous delivery and technology and a lot of hardcore engineering practices that make it possible for us to actually start to deliver better systems to our customers. So this cycle goes like this. We want to start with a testable hypothesis. We want to say, I think if I do this, something will get better. I will have more sales. More people will take my airplane flights. My supply chain will run more smoothly. I will get my inventory more quickly. I want to have a hypothesis, and I want it to be testable. I want to know whether I've succeeded or not. And then I need to figure out how to develop this as quickly as possible so that I can get it out and find out, am I right or am I wrong? And I want to do this quickly, but I also want to do it safely. I don't want to take a whole lot of risks, because if I'm going to go to my senior leadership and say, I want to release once a week or once a month, the first thing they're going to say is, and how many of those releases are going to fail? How many times are you going to bring down my system? And so I have to be able to reassure them that all of these releases will be safe. And then I want to measure, did I actually succeed? The number of business cases that I've seen in this industry, millions of dollars, thousands of jobs saved. No one ever goes back and checks. No one ever says, oh yes, my PeopleSoft implementation saved the $17.5 million in the first 3 months that I said it would. No one ever measures it. But we have to start measuring it. And yes, what this means is we are experimenting on our customers. We are coming up with a hypothesis, because we can't afford the old-fashioned focus groups where you brought people in and bribed them with ice cream and asked them to look at things and say whether or not it would cause you to buy more stuff. Those don't work anymore. They're not fast enough. And in fact, people didn't answer honestly anyway. They don't know how they're going to behave. You're asking them in a sterile office whether or not they're going to respond in a particular way. And that's not just how it works. So we need to be able to safely experiment on some of our customers to see, will this give me more sales? Will this increase my time to market? Will this speed up my supply chain? And we need to keep doing this. So what does it actually take to do this? It takes a lot of things. First thing, we have to be prepared to change quickly. And we have to be prepared organizationally to accept failure. Because if you try lots of things, if you're taking risks and experimenting, occasionally you're going to get it wrong. And organizationally, it can't be a problem if you get something wrong, as long as you were doing the right thing. We have to make it okay to fail and to pivot. If that Lean Enterprise book gave us anything, it was, or the Lean Startup book, it gave us this word to say, oops, I got it wrong, but if I just go this way, it'll be great. So pivot has kind of replaced this, oh, I tried an experiment and it didn't work. But organizationally, we have to get better at allowing people to fail, because if you are not trying any experiments that go horribly wrong, you're not taking enough risks. And someone is going to take that risk, and they're going to beat you to it. And what you really don't want to tell your boss is, actually, I thought of that, but it was too risky. We have to know how well we're doing. not just as a delivery team, and Agile software development has given us all kinds of visibility into how we are actually progressing on development, but we also have to know how our business metrics are going. How is our business doing? How am I advancing on this hypothesis? So we have to measure all kinds of things in real time in our business to understand how we're doing. And you got to get the granularity right. When we're talking about lots of experiments, you want these things to be narrowly scoped. You want these to be something that you can put out and test quickly, know quickly if it's working or not. And if it didn't work, well, you've limited the scope, you've limited the amount of work that you've done. Hopefully you've learned something so you can use the pivot card. But you want to make sure that these things are small enough ideas, and that means you're going to have lots of them. You want to run lots and lots of experiments, and you don't want to limit who gets to propose them, because you never know where the next great idea is going to come from. We have to then be able to balance how much we know we can do and what we want to go after. So balance predictability and opportunities. And then finally, rely on evidence and not guesses. The number of times I have been asked, what is the technology landscape going to be like in 5 years' time? And I just laugh at them. Because if you think back 5 years, how different is the world today? I don't know of anybody who could have predicted that. I just got the opportunity to hear Ray Kurzweil's talk. And he's actually pretty good at things 25 or 30 years out. But even he doesn't want to talk about the next 3 to 5, because who knows? So we need to figure out how we can get evidence rather than guessing at things. Okay? So that's a nice lofty agenda. How do we actually make it work? There are several techniques that we've developed over the last several years to support software development that is going to allow us to do this. Continuous design. This process of continually looking at what do your customers really want and how can I deliver it to them. Continuous delivery. We'll talk about both of these in more detail later. Pragmatic software quality. You can't go fast on bad code. It just doesn't happen. So how do you actually deal with that? Evolutionary architecture. How do we start thinking about making our systems at that architectural level more flexible? And then unfortunately, we have to think about the people. I would far rather think about programs and systems and architectures, but we also have to think about the people. So let's start with pragmatic internal quality. As a geek, as a former academic, I would love for all code to be beautiful at all times and to be able to throw away any bad code that exists on the planet. Even I am not so naive that I think I can do that. So we need to think instead, what do I actually need? What is it that I can do that I actually need to be able to make progress? And what does it take to get there? And the first thing we want to think about in this regard is that what's really important about software quality is how easy is it for any one of you to pick up your neighbor's code and understand what it does. Writing software doesn't take the time. Even fixing software doesn't take the time. Figuring out what to do to fix the software is what takes time. And you can only do that if you understand what the software does. And so over the years, we've been developing lots of metrics and a pretty good understanding of what it takes for us to understand what a piece of code does. And please don't tell me if we just did more comments or better comments, that would solve the problem. Because no one maintains comments. And actually, what makes sense to you today won't even necessarily make sense to you in 18 months' time, let alone somebody understanding what your comment meant when they're looking at it in 18 months' time. Another thing to think about with software metrics, it's not necessarily a given point in time that you're worried about. It's how the thing is trending. And if you're looking at metrics and they're going like this, and then all of a sudden they fall into the abyss. You want to go back and look at what happened. Maybe you've run across a part of the problem that is, in fact, much more inherently complex than anything you've seen before. Maybe, as happened to us once on one of our projects, we got a new project manager who was really going to crack the whip on the delivery team, and all of a sudden, imagine what happens. You stop pairing, you stop testing, and your code quality goes into the toilet. So you want to watch these trends over time, because the point at which that curve changes, that's giving you a piece of information that you should act on. And there are always going to be these scope quality trade-offs. Sometimes the right business decision is to stop the line, is to clean things up. Sometimes the right business decision is to do whatever it takes to get it over the line at a particular date. I worked on a project at one point where if we hit the first date, the government would give the company a bonus. If we hit the second date, the company wouldn't be in trouble, but they wouldn't get the bonus. If we didn't make it until the third date, they got fined every single day it was late. So it was really important not to go past that date. And yes, we made compromises, but we made actually the middle date. So we didn't get the bonus. It was a tight deadline anyway, but at least they didn't get fined and they didn't lose their protections. So we have to talk about those things. We have to make those trade-offs. So if you are the lucky person who gets to write only greenfield software and never look at anybody's code that's been written in the last decade, let alone 50 years ago, most of us aren't in that situation. Where do you start when you've got a pile of mud? And I look for several things. The first is, yes, run the quality metrics over the entire code base. Make a note of the fact of the parts of the code that you can't analyze because it actually throws an arithmetic expression when it tries to compute the complexity, and you just make a note of that and go on. But then you start to look at what is really going to change. Talk to your business users about their plans for the business and try to figure out, okay, does that mean this thing is going to change? Look at your commit logs, since hopefully we are now at the time when if I asked, and I'm not going to ask just in case, that everybody's now using source control, so you actually have a commit log and know how often parts of your system change. That wasn't always true. Might not still be true. Look to see where changes are made. If you've got a horrible pile of mud sitting over here that nobody's even looked at in 5 years, don't pay attention to it now, unless your business user says, oh, by the way, we're resurrecting this product line, so we got to do something over here. Maybe by the time you have to do anything, you can, in fact, throw it away. Very important, ask your operations people, and if you have them, a quality department. When do you get nervous? When you start to get the change logs from delivery that's telling you what's going to change, what makes you nervous? When do you know you're going to get called in the middle of the night because this thing really isn't going to work, because it never works the first time? Find out where those things are and prioritize them. So use all those things about how likely am I going to be to have to actually read this code and marry it up with how bad the code is. And that's how you prioritize. And that's actually also how you convince your boss that this is a smart use of time. If you've got a high probability that you're going to have to change this code, there's a high probability if you try, you're going to get it wrong. And because it is so dirty, you've got a pretty good chance that they'll allow you to clean it up. Particularly if you say, and oh, by the way, I've put into my build this software quality metric, so I'll know if it gets bad again. Because that's the other common question. Okay, I'll give you a month to clean up this entire code base. Do what you can. How do I know you're not going to be back here next year asking for another month. And that's your answer, because now we're going to monitor it. And it's never going to get this bad, because when we start to see things go wrong, we're going to fix it right away, when it's easier to fix. Now, sometimes you do have to face this pile, this ball of mud, this ball of string, this bowl of spaghetti, whatever you want to call it. There's something that I think is underused in our industry, and it's called the Strangler Pattern. Now, this is not a homicidal maniac pattern. This is actually based off the strangler fig tree, which grows up around another tree and uses that old tree for support. And this is what the strangler pattern is all about. You've got this legacy system that is still really important. What do you have to do to make it usable in your new context? You're going to have to strangle it. You're going to have to build some kind of infrastructure around it. You're going to have to allow for the flow both in and out of that legacy system. So you've got this migration of information and activity back and forth across that. You're going to have to figure out some way of capturing events and figuring out, does this go to the new place or the old place? And that is going to allow you incrementally to replace that legacy system. We did this once at a client in the UK, and we kept asking them, will you now let us turn off the legacy system? We think we have transitioned everything. And they said, no, we're not convinced you're done yet. We didn't do this, I swear. Someone else shut down the computer that ran the legacy system. It was an old desktop machine that was literally sitting under somebody's desk. And no one noticed. It was turned off for 6 weeks before the person fessed up and said, yeah, actually, I shut that thing down 6 weeks ago. So this is something that you really should consider. You can incrementally replace that legacy system, and if you can do it right, you don't actually have to read what's inside. You just have to understand the inputs and the outputs. Now, evolutionary architecture. This is one of my favorite topics. I will try not to talk all day. But the principles of evolutionary architecture really get down to what can we do to break this notion that architecture is hard to change. Because actually some people define architecture as those parts of the system that are hard to change. Now that's a way to set yourself up for failure at the beginning. So we've developed several different techniques that will actually allow us to change some of these things more rapidly. A couple I want to call out first. Think about how you communicate, not just messages, but databases. Pastel's law. Be very cautious about what you send. The minute you start making data available, people are going to start using it. And as soon as they start using it, they're going to start to expect it. There was a time when everybody thought what you should do in an enterprise system is just put the full object in all of its glory out every time you were communicating. That was a massive, massive increase in coupling, because now all of these systems knew about all of the data, and they all used it in whatever way they wanted to. And so you could never change anything. The second part of the law is what to do about what you read. Be very forgiving in what you read. If you're getting an address and all you need is a postcode to do some kind of geolocation, don't parse the rest of the address. Why should you care whether they have 2 address lines or 1? You shouldn't. You don't care. All you care about is that one piece of data. Obviously, the big asterisk, don't do anything stupid around validation that opens you up for security hacks. But don't validate things that you don't need. Figure out a way to just ignore that, so that if somebody does change their system and break up their address field or recombine it, your system doesn't break. You can't guarantee that you'll never break, but you can at least guarantee that you will only break if there's no other choice. And of course, since I'm from ThoughtWorks, I have to talk about testing. Yes. But one of the things actually that we have found is if you pay attention to how easy or hard something is to test, you'll actually end up with an architecture that's very easy to change. Because the things you worry about testing, let's make sure there isn't this huge and clause of what the test is supposed to be testing, which you have to do if you have these modules that do all of these different unrelated things. Let's make sure that it's easy to get at the things that we need to understand. This is where a lot of big enterprise software suites fail, because they put all of this business logic in places that's really hard to test. You'll get good separation of concerns. You'll have good APIs. It will be easy to understand how these things interact with each other. So if you focus on how hard something is to test, you'll actually be focusing on how good your architecture is. One of my personal favorites is the last responsible moment. Part of how we get into trouble, particularly in the waterfall scenario, is at the beginning of the project, you have to write this list of all of the frameworks and all of the tools and all of the system software that you're going to need. How you're supposed to know that at the beginning is unclear. And then you have to go to first your enterprise architecture group and get the approved list. And maybe you have to go to procurement and have them buy it for you before you've even thought about what the code might look like. Every time you do this, every time you end up with a tool that is more than what you need or different from what you need, you introduce technical debt. This was mentioned, technical debt was mentioned this morning. Think about what it means. You have a debt. There are two components to debt. There's the principal, which you have to pay down. That's when you clean it up. And there's the interest. What does it cost you while you're carrying it? What technical debt costs you is in development time, because everything slows down. Using the wrong tools, particularly a heavier tool, a more complicated tool than you need, slows your development down. Now, all problems are not solved automagically. Sorry. We can't. This is not going to make your leadership make sensible decisions. This is not going to mean that you're never going to have breaking changes that happen. This is a way to limit the damage. This is a way to start thinking about how I can get something out quickly without compromising my ability later on to change it. Other techniques like refactoring databases, which allow us to actually safely migrate data, which is one of the single hardest problems that sounds so trivial to state, I think, in our business. There are all kinds of techniques, microservices architectures, messaging systems or event systems. We've got all kinds of architectures that now exist that make it easier for us to change things. That doesn't mean it's easy. You need to distinguish between what is relatively easier to do and what is easy. So, what about continuous delivery? I actually believe that many of the innovations that we're seeing now in architecture, microservices, many of the rapid deployments that we're seeing only are possible because of continuous delivery. People think about continuous delivery as this end-to-end automation of deployment and how it makes it fast and how you can start day one at one of the fancy new internet companies and on your first day commit code that goes into production and nobody sees it. To me, that is a definite benefit, and we'll talk a bit about that. But the biggest benefit is the fact that if you automate something, it's going to happen that way. And I don't know how many of you have been the lucky person like I have of being there at 3 o'clock in the morning on a Sunday, trying to install the latest version of the software, And you might have a perfectly lovely run book that does, in fact, have all of the instructions. But I'm not at my best at 3 o'clock on a Sunday morning, and I don't think anybody is. The disciplines around continuous delivery actually de-risk deployment by taking out the random variable that is humans. So what is it about continuous delivery that's so important? Yes, the ability to deploy automatically into production is part of that, but it's all the things you have to do to make that possible. The way you have to standardize the environments, the way you have to automate all the deployments, which means you have to figure out how you make these systems that were actually designed for somebody to sit at 3 o'clock on a Sunday morning dragging things across the screen. Because isn't it wonderful to have a graphical user interface to configure your system software? Sounds like a good idea until you do it at 3 o'clock in the morning. You have to automate all the things. That's the first order of continuous delivery. And there's a lot that goes into that. But the good news is, even just automating 1 or 2 of the things already incrementally helps you. You don't have to go from kindergarten, or whatever the equivalent is here in Chile, toddlers, to a postdoctoral degree to get any benefits. This is one of those things that just doing a little bit gets you a lot of benefits. You can't also do this without a testing safety net. We need to know we've got good unit test coverage. We need to know we've got good end-to-end coverage. We need to know we understand all of the integration points that are happening between the various components of our system. And these tests need to be automated because we're going to do them a lot. And the result of this is the decision to deploy is no longer a technology decision. It's a business decision. They might decide to wait for a couple of days because of something that's happening. They might decide to move it up because they want to take advantage of something that's happened. Retailers see spikes in demand all the time because of particular activities. Just ask the people who are in the hurricane zones on the sales of bottled water and how constant that is. If you've got an opportunity to take advantage of something that's happened in the world, you want to be able to do it. So it puts the decision in the hands of the business users, not the operations team, when to deploy. Now, one thing I get asked a lot is, how do I handle this whole process of letting some random developer check in and something appearing in production? You can read that entire continuous delivery book. There is nothing in that book that says you can't have a big green button sitting on the CEO's desk and nothing goes into production until he slaps the button. There's nothing wrong with that. There's nothing that says you can't have manual steps. There's nothing that says you can't have some kind of manual review. It's the fact that it can go through that's important, not that it does. So you can insert your sign-offs, your security reviews, any of those things, and still do continuous delivery. There's nothing wrong with manual intervention. And there are a lot of people who get very nervous about continuous delivery because they don't accept this. That's why I beat on about it. Just because you can doesn't mean you have to. So now let's talk about continuous design. I've been involved in agile software development for quite a while. And at the beginning, the process was, sure, developers can do this, but I'm an analyst. And when I think about my story, I have to think about all of the possibilities before I can turn it over. And the analysts actually came on board fairly quickly with this whole thing about let's break things down into smaller stories. But the QAs then, oh, sure, you guys can do it that way, but I have to test the entire application because if you change it, then I have to redo my tests. It's like, well, if you have 300 bugs, when you first test it, I'm going to have to change it a lot too. So wouldn't it be better to get some of those out of the way earlier? And they eventually came on board. I think one of the legitimate objections to Agile was actually from the database administrators. Because as I said earlier, data migration is hard. It never goes as smoothly as you think. And so the work that's been done by Pramod Sadalog and Scott Ambler in the book Refactoring Databases addresses exactly that problem. How do you allow yourself to make even major structural changes to your database and still safely migrate? And so they're starting to come along, as are the architects. Designers are in the same boat, though. Think about what a user experience designer does as they face a problem. What is going to be the unified user experience? How is this journey going to go through all of the different stages of that user journey? What are all the user journeys? Again, we're starting to get to the point where they can think, okay, here's the design equivalent of the metaphor, the unifying metaphor that XP talked about. What is that overarching journey? What are the characteristics of the interaction that I want to maintain? And I can make all those decisions without giving a pixel-perfect layout of all the screens in the system. So we're starting to understand what it means to do continuous design, how I can establish the characteristics of my interaction, and then allow the designer, as we come up with new ideas, oh, well, this is how this thing is going to change. And this whole process of continuous design has become important because the expectations of our users have increased. For those of you who had to work on, or might still have to work on, systems that were built 30 and 40 years ago, the user interfaces are terrible, absolutely terrible. I've watched people try to contort their fingers because they have to press so many different keys in so many different ways. They're awful. We won't accept that anymore. Consumers won't accept it, clearly, but employees won't accept it either. Why in the world does this thing work so clunky when Twitter and Facebook are so easy for me to use? We have come to a point where we can't not worry about who the user of a system is. And so this whole thinking around user-centered design and how we insert that into an agile software delivery process is part and parcel of how we get business agility. Your customers all have too many options. So if you don't continue to improve that experience, they will go elsewhere. And so this design and design thinking has become much more important, certainly than when I started. I didn't have to worry about that stuff. I had a green screen to deal with, like this one. Okay, so what about these pesky people? One of the ways I look like a magician is I will come in to an organization and they want me to analyze their architecture. And I go and I watch the lunchroom. And I see how the tech leads of the various teams interact at lunch. And I come back and say, that part of your system is broken. It's like, how in the world do you know that? You haven't looked at a piece of code. So I watched the two tech leads. They don't like each other. They don't talk to each other. Therefore, those two systems don't work well together. This is a corollary, if you will, of something called Conway's Law, which says, essentially, that an organization is destined to create systems that mimic their communication patterns. If you have silos in your organization, you will have silos in your system. If you have broken communication between two parts of your company, those systems will not talk well with each other. That is Conway's Law. We have another problem. We have this dilemma. Back around the time of the year 2000, when we had the famous book that said IT is now going to be irrelevant, and everybody was all concerned about costs. We got in CIOs whose mandate was to drive down costs. And how do you drive down costs? You standardize. You stabilize. No, you're not going to release every month. You're going to release every 6 months. No, you're not going to use that thing that makes you run faster because I don't know it. And I don't have a license for it, and I don't have someone who can support it. So no, you're not going to have that. And then all of a sudden, technology became important. And these boards are coming down to the CIO and saying, move fast, move fast, move fast. The kind of person, the kind of organization, the processes, the tools, the people, the reporting lines, the governance is very different if you're trying to cut costs versus trying to go fast. The same organization cannot do both well. So you got to figure out what to do, because you cannot escape Conway's law. It will haunt you. So what you need to do is you need to take advantage of Conway's law. You think about the kind of system you want and change your organization to match that, and use Conway's law to help drive your system in the right direction. You need to consider, what is it that makes your company special in its market? And focus your attention there. Very few organizations differentiate themselves on their payroll system. So don't worry about your payroll system. That is a utility. Give that to somebody else. You probably differentiate yourself, though, on the customer experience and the way the customer consumes your services. Walmart differentiates itself on its supply chain. It can charge what it charges because its supply chain is so good. That's a key differentiator for them. For many organizations, it isn't. So figure out what it is that differentiates you, what it is that you want to achieve, and then structure your organization around it. We call this the reverse Conway maneuver, using Conway's law to help us. So our goal is business agility. Our goal is to, as technologists, enable our companies to deliver value to our customers faster, to enable our companies to experiment and understand what it is our customers might want next, what is it our competitors might be getting ready to come out with that maybe we can beat them to the punch. This is what our goal is. And we do that by thinking about how easy it is to evolve our systems. And I talk specifically here about evolvability, not adaptability. And that might not translate well from Spanish, so let me try to explain. When I talk to people and they say, I want my system to be adaptive, they mean, I'm going to figure out all the different ways this system is going to need to change. And I'm going to put a configuration parameter here, and I'm going to put some kind of throttle over here so that I can change the numbers and maybe even change the processing based on where that knob is set. But the key thing is they're predicting where the change is coming from. And that's what adaptability means to most people. Evolvability, on the other hand, you don't know where the change is coming from. You don't know what Facebook is going to release. You don't know what kind of regulation might come out. You don't know what many of these environmental factors that impact your systems, you don't know what the change is going to be. We left that world decades ago. So you want to architect in such a way that regardless of the kind of change, it is as easy as possible to change. So you build in things that allow you to swap things out more quickly, even if you had no idea you were going to have to change it. And that's what it means to keep these systems poised for change. They're ready to be changed. This is also where that software quality comes in. You have to constantly be analyzing that backlog of all those bad numbers that you got on your software quality metrics so that you can over time pay that down, so you can increase your probability that you are going to be able to respond to one of these things. Because all those things I told you, that's a good place to start, and it's a good argument to make to your boss about why you want to do those things, but there's no guarantee that's where the change is going to be. We need to lower both the cost and the risk of experimentation. So this is the cultural. It can't be career-ending to have an experiment that doesn't succeed. We have to make sure that we can safely deploy, and perhaps using things like feature toggles that was again mentioned this morning, turn it off if it doesn't work quite the way we thought. We need to make sure that we have rapid feedback about how things are going, internal to our organization, as well as to our customers, as well as in the market. And then we have to figure out what to do with these pesky people. We have to figure out, how do we motivate people? How do we organize them? How do we encourage collaboration? How do we encourage risk-taking? How do we do governance? Governance doesn't go away in this model. There isn't anything magical. We still have to know what's going on. How do we do that? How do we make sure teams collaborate with each other? And how do we make sure that the organization is properly poised to take advantage of the opportunities that are going to come? And the problem for many organizations is they are having to reimagine who they are. I worked with an insurance company a few years ago, and they were really upset, actually several years ago, I guess. They had differentiated themselves literally for decades by the precision of their ability to price insurance policies. And this was for homeowners insurance. They had 87 parameters. And then some brilliant person said, let's quote online. How many of you would fill out a form with 87 questions just to get a quote from an insurance company you don't deal with? Didn't think so. They had to completely reimagine themselves because they thought they were an insurance company. Their differentiator was this whole department that maintained this model, and now they had to rethink who they were. And that changed the organizational structures. It changed their processes. That's the kind of change that's going in all of these organizations. It goes by several names: agile transformations, digital transformations, post-digital, whatever that means. But this is the core of what is happening. All of the people that you work for are having to reimagine what is their place. How does their company continue to make money? How is my industry going to change? And we, as software professionals, have to be in a position where we allow our organizations to evolve those systems to meet those needs. And hopefully this has given you some ideas on how to do that. Gracias.
Thank you, Rebecca. Preguntas. Tenemos
Hear me,
tiempo para
Rebecca?
preguntas. Una acá.
Can you hear me?
Yes.
Hello, here. Really,
In English.
on the context of explaining about architecting for real evolvability, is it really just about reducing coupling, or can you expand a bit more on that?
Well, coupling is clearly part of it. But it's not just coupling. When you think about sorry. When you think about how you're going to divide up functionality, coupling does restrict changes, but so do organizational barriers. So do technology choices. So you can't have an interesting conversation about architecture without talking about coupling, but that is only one aspect of it, unless you take a very broad definition of coupling. Some people, for example, will say two systems are tightly coupled because they exchange a message. I don't consider that tight coupling. I do consider coupling, for example, though, if you have a system that's a package that's running a database, and somebody else says, it's a whole lot easier to write my report if I just ping the database, that's a form of, that is a form of tight coupling, which unfortunately we still see way too much of. Thank you. You're welcome.
¿Más preguntas? Ajá.
Hi, thank you for your talk. You talked about the Conway law.
Yes.
How do you deal with your customer? Because you can change the customer organization. So what is your organization to deal with or to abort that kind of project?
So the first thing we do is actually point it out, because very often people don't realize how easy it is to, for example, figure out that that's the broken system. And then we talk to them about, okay, what are you trying to achieve with the organization that you have? The most common answer is cost. If I have my group of developers over there, my group of analysts here, my PMs over here, and somebody gives me a request for 2.7 developers, and I'll bring 2, and then I'll only allocate this guy 3/4 of the time, and they can keep their headcount down. Well, that's a disaster for maintaining the kind of systems that we are doing. But you can only counter that argument if you know that what they're trying to do is save costs with that. So understand why they have the organization that they do, and then try to help them see what they could achieve if they change things around. And very often that takes a demonstration. So we'll say, okay, you give me a team. Ideally, you give me 2 teams working together where we can say, here's how the functionality should line up, and therefore here's how the teams are going to line up, and show them how much more effective it is. Because you're right. Very rarely am I brought in and given a blank sheet of paper. I was once, and that was very scary, because you don't want me designing your organization. Trust me on that one. But the first thing really is to help them see that they have a problem in the first place. Because even though a lot of technical people understand Conway's law, a lot of people in other parts of the organization, they don't see it. And they see that they want to organize things around systems rather than around business capabilities. And that's really the shift that has to happen in their mind.
Yeah, great talk. Thank you so much. In this world, when we need to put the agility and speed to market over cost saving, and this, I don't say that the enterprise architects have had this role for several years, right? To standardize things because of the cost saving. So, what is the role of the architect in these organizations that want to be more agile, with more velocity and these kind of things?
The basic role of the enterprise architect doesn't change. More, it's how they do their job. There are lots of people who work for ThoughtWorks who think that enterprise architects play no useful role, and I think they're wrong. Particularly in large enterprises, someone has to look out after the whole estate. Someone has to understand how things actually happen within the technology stack, and that's the architect's job. And that job is in fundamental conflict with how we design our delivery teams. A delivery team is responsible to a particular business owner for a particular business objective, and they want to get it done as quickly as possible for the lowest cost. And usually in that order from the business person's mind: fast and then cost. The enterprise architect has to think about what that thing's going to look like in 5 years. How hard is it to maintain? How expensive are the skills? How difficult is it to recover the system if it shuts down. So those roles still exist. The difference now is how the architect does its job, does his or her job. And this is that governance thing I was talking about. We need to have different ways of engaging between architecture groups and delivery teams. And part of that is also going to come from changing the perception of architects within organizations, and not just within the development organization, because we know all the developers always hate all the architects, but also in the rest of the organization, because right now, architects in general are seen as overhead. The delivery teams are the ones that get code out the door. The architects are the overhead. And what does any organization do with overhead? They try to squish it. So I've seen organizations where you have on the order of 20 or 30 architects responsible for 1,000 plus delivery projects, not delivery personnel, delivery projects. Just do the math. How often could they even spend 4 hours with each one of those projects? The math doesn't work. So the only way they can engage is through these document-driven declarations from on high, thou shalt, which the delivery teams just ignore. And the only way we can change that perception is help organizations understand that architects can, in fact, help top-line value. They are not just overhead. But they have to change the way they engage with the delivery teams in order to do that. And there is probably, there are definitely people in that architecture role who couldn't transition to the new role.
Hello.
Yes.
My question is about the evolved architecture. You mentioned that we create a solution that should evolve on time, right? Mm-hmm. But when we design a solution that should evolve, we need to think in abstractions. Abstracts everything, maybe. So my question is how you scope that kind of abstraction, because even we didn't know what could happen in 3 months or maybe what could happen in the 3 years, right? How you scope that instead don't allow that the engineer or the software engineer that is keep looping and imagine what abstraction that they should support in the near future, for example.
The abstractions need to evolve over time as well. This kind of goes back to that point about rely on evidence, not guesses. We're often brought in and people say, I want to build a platform, and then I'm going to build products on top of the platform. And my question is always first, how do you know what to put in the platform if you don't know what products you're going to build on top of it? And so you want to build the platform along with the first 2 or 3 products where you start to see what are the useful abstractions. We've gotten ourselves in trouble so many times over the years with trying to build this ideal view of the customer that everyone will use, or this ideal view of the product that everyone will use, without really understanding how those things get used and what really is the core abstraction, which we can continue to reuse, and what are the things that we do actually have to allow for specialization. Those things emerge as we are building real products on top of these APIs and platforms, or on these databases. So we want to be in a position where we can evolve those abstractions. And I can tell you that you can make even some fundamental changes to your abstraction hierarchy if you have the right testing safety net. I was in a situation, we had approximately 650,000 lines of Java code. And we had a particular top-level relationship that we had to flip. When we got to new functionality and we realized the abstractions that we had set up didn't work, that change was able to be made by one pair in 1 week because we had the right kind of unit test harness around it. And so if you take this stuff seriously, you can evolve abstractions, just like you can evolve other things. You can change out those abstractions, and you have to accept that that's what's going to happen. Because regardless of how hard you try, today, your abstraction might be perfect. 18 months from now, it probably isn't.
Un fuerte aplauso para Rebecca Parsons.